Now, example 10 is an example that, so this is a dependent one, you see, where the probability changed based on you not putting the card back. But if it's a coin is tossed and a die is rolled, we've got a coin and a die, probability of tossing a head and then rolling a 6. So tossing a heads on the coin is 1/2, 1 out of 2 there, and then rolling a 6 would be 1 out of 6. Notice that the dice isn't affected by the coin because they're independent. That would be 1 out of 12 chance for that to happen. Okay, last one, we got kind of some complicated stuff here. For a rotator cuff surgery, the probability that the surgery is successful is 0.9. That means 90% chance. Find the probability that 3 rotator cuff surgeries are successful in a row. So this one, and that one, and that one, and means multiply. And means multiply. I wrote it up here by the multiplication rule. Okay. Find the probability that the 3 rotator cuff surgeries are successful in a row. So we have a success, and a success, and a success. So that would be 0.9 times probability of 0.9 times probability of 0.9. These are all independent because if one surgery goes well, it doesn't mean that automatically another surgery is going to go well. If you multiply those together, you get 0.729 probability, about a 73% chance that you would have 3 surgeries successful in a row. Find the probability that none of them are successful. Okay, so none of them. Well, if a surgery is successful, that's 0.9, so that means that unsuccessful is 0.1. So I'm going to write no, 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 and that would be 0.1 times 0.1 times 0.1, probability of all of them being not successful. 0.1 to the 3rd power is 0.001. Find the probability that at least 1 are successful. Okay, now this is one where it's easier to find a complement, because if at least one of the surgeries is successful, that means that if I was going to do this right, I'd have to find the probability that like the first one is successful plus the probability that like the second one is successful plus the probability that the third one is the success one, and none of the others are successful. Plus, I'd have to find the probability that 2 are successful and 1 is not. Or it's the first one that is successful, the second one isn't, the third one is successful, or, you know, vice versa. Or that all 3 of them succeeded. And we'd have to figure out, we'd have to do this kind of math, like this 0.729 is just that one. So we'd have to do all of those maths together to figure it out. Or we can just do the complement. And the complement says that if you have 100% probability, that I can take away the probability that none of them are successful, because that's really the only thing that can't happen. Somebody has to succeed at some time, and the only thing that can't happen is that none of them are successful. So I'm going to take 100% minus 0.001, and that is 0.999, so that's the probability of at least one of them being successful. If you were to figure out the probability of this one, and 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 add them all together, they would end up being 0.999. All right. The assignment is on the bottom of the sheet. It's evens. You do not have to explain anything. And then these ones are also evens, and then number 32. So go ahead and go through them. The answer key should be provided by Mr. Young. I am likely at this point, snuggling a baby probably, not tired yet. We'll see how tired I am the next day though. Miss you guys. Bye.